Thank you for watching Knowledge Academy.
We talk about fundamental theorem of calculus, right? We talk about fundamental theorem of calculus. And what this calculus theorem is, if you have any limit is given a to b, and I take the differential, the integral of a differential function is going to be equals to, I take the function, substitute the value of b minus function, take the value of a, right? And this is pretty much what is a fundamental for line theorem. This is how it works. So in this theorem, suppose if you are talking about fundamental theorem of line integral, fundamental theorem is going to be follow the same methodology. The only difference is that you're going to write few things. Suppose that C is a smooth curve given by R T, and it basically go from A to B. These are the two limits. So maybe this is like a smooth curve. Smooth curve means the curve like this, the curve like this. This is also smooth curve, or the maybe the curve like this, or the curve like that. That is a smooth curve. What is a non-smooth curve? Is the curve like that. Yeah, this curve is not continuous. Yeah, you can say this is a curve, but this is a curve, but there's a problem here. This is not smooth. The line integral theorem have challenges. They're not going to be, you cannot use that in these kind of scenarios. So if C is a smooth curve given by RT, R go from A to B, so A is this, maybe B is this. Here A is this, and if you take a complete turn, the B is this. Here A is this, and B is this. So it's nothing but it's just a limit of these for curve, right? Or whatever you're interested to, you calculate. These are the two values you want to be interested between the two, right? Also suppose that f is a function. So we are talking about R, and now we're talking about the function f, whose gradient vector this is continuous on C, is continuous on C. And what does that mean? It means let's suppose f is a vector, it has a field, right? This vector supposed to be following this, it's just follow this. You cannot say that, yeah, in this portion there is no field and then it's going on like this, you know. So if this field is empty, then again we have a problem. You cannot substitute this value. The two condition is the function is continuous. It means it does not have an inclination point or hiccup. It does not have any kind of sharp hiccup or sharp inclination. Second thing, we do not have a non-continuous function. So this field have the function, right? Let's suppose your weight. Your weight is continuous, yes. You go anywhere, you have your weight with you, yes, always. You go elevators, in your apartment, in your house, in your bedroom, restroom, wherever you go, your weight is with you, right? But let's suppose you have your phone with you, it has a magnetic field, and you are walking in let's suppose you go to the walk and you have a magnetic field in your hand, which is your cell phone, and somehow during your walk your cell phone die and the battery just gone. You're still walking, right? But you still have the track, but you don't have the function because the cell phone is no longer powered, so there is no magnetic field. So you cannot apply the line integral theorem on that scenario. And how can I write? I write like this. You know how we write like line theorem? We did some problem yesterday. This is how we write the line integral. But how we solve it on the other side. The right side is always I'm going to be writing moving forward. The right side is the one what I'm going to be solving. The left side is the theorem or my unknown. The right side is the one what I'm going to be solving. So right side is this. That's how I'm going to be writing. Then minus, I'm going to say is this. It's inside the parentheses. Then minus r a with function and then parenthesis close. Right. This parenthesis also close here. Okay, so we always have two things going on. We take the function, substitute the value for whatever the b is coordinate, and then take the function, substitute the value for the initial coordinate, and we can figure it out. What are the 2 points? Okay, and that is my line integral theorem, or fundamental line integral theorem. Why do we call fundamental? Because it's a fundamental. The next stage is called Green theorem, then Stokes, then Navier-Stokes theorem. So what you're gonna do? We're gonna talk about typical way we writing this line integral, and then fundamental line integral theorem. So what I'm gonna do? I'm gonna take an example, and then we can solve this example with the traditional way, and then we can solve the same example with line integral, fundamental theorem of line integral, and see how cool is that. Let f is a function f is x y equals to 2t. I'm going to say in x form, just keep it into the parametric form later. 4y 2x 4y, calculate this. Okay, how do we know this is a line integral? Because this is a vector, and that's a position vector, and c means curve. This c actually telling me this is talking about line integral. I'm not talking about the fundamental theorem of line integral right now. I'm talking about just a question telling you this is a line integral theorem because this c telling me curve, where c is a segment from something to something, from 0 to 2. Yeah, so let's put it this way. In the natural prospect, you have a field. Look at that, 2x 4y, 2x 4y. It means if I ask him to draw this field, it's going to be look like 2x 4y. So it's going too much on y but too less on x. So maybe the field is look like you can draw this kind of field on other side too, but because of this we're gonna save some time, so we're not gonna draw. You can draw here, it's gonna be go this way, this way, and here you're gonna be going this way, here you're gonna be going this way, but I'm interested only in the first quadrant. That's what I'm looking. And what I'm gonna do, I'm gonna take this curve and it says 0 0 2 2 0 0 and 2 2, maybe it says 2 here and then 2 here, so 2 2 is my here, and this is my point p2 2 2, and then p1 is 0 0. And what I want, I just make a line, and that's what I want to go from one point to another. That's my line, the red line I'm going to be follow for this integral. Okay, so let's start it. I'm going to be doing pretty much traditional way first. So we use and this is a field is given. So this is a function is not look like is a vector, is not a the vector field is basically a scalar. So I'm using fds. If it's a vector function giving the vector form, you just apply f dot dr. you can take this one and t ds equals to a b f r then t dot r prime t. Okay, so here what we need to do, we need to find the rt, right? So let's do rt equals to 2t comma 2t. How we come up with this? We assuming x equals to t, right? X equals to t, so my x coordinate, this coordinate is becomes 2t, and y equals to x, so I can say y equals to 2x, so it's going to become 2t, so it's going to be 2t as well. Okay, if I substitute the value of t, I'm going to get 2x. If I substitute the value of other side, which is my segment is going from 1, so I can get the other corner, other coordinate. So I'm going to write here 0 t going to 1. If I substitute 0, I get first coordinate. If I go to the other coordinate I'm substituting, I get the other point, like which t is to 1. 0 0 2 2. So if I substitute 1, it's going to be 2 2, and if I substitute 0, it's going to be 0 0. That's how I got these two values. All right, so we can get this one. And another way is that you can say is x equals to x naught plus at, y equals to y naught plus at. So this x naught 0, y naught is 0. How? Because these are the 0. This is my x naught, y naught. And a and b is the vector. So how do we calculate a? It's basically the difference of the two coordinates. So x a equals to 2 minus 0, so it's 2, and b equals to 2 minus 0, which is also 2. So that's why how we get our x equals to 2t, y equals to 2t. That's another way to look. Okay, I told you both method, but that's my parametric coordinate system I created. And what I'm going to do, I'm going to take my function and then substitute these values into my function. My function is 2x comma 4y. These are the coordinates. So I'm going to say is 2x comma 4y. I'm going to substitute these two values here. So it becomes 4t, right? 40 comma 80. And my r prime, maybe I can say my r prime here, t equals to, I just take the differential of this one, is going to be 2 comma 2. Okay, so everything is written here. All I can do is just substitute the value and see how does it go. So I'm going to say this dot dr equals to 4t comma 8t dot, then I'm going to writing my r vector, the r prime 2 comma 2, and then dt. Okay, this pretty much is done. All I can do is just simplify it before I take the integral. So it's going to be this one time this one is going to be 8t, maybe 1 and 0, 8t plus 8 times 2 is going to be 16t, and then dt. I'm going to be taking the integral, but before than that I think I can simplify it further. I can say is 24t dt. And if I'm going to do here, it's going to be 12, because 24 divided by 2 is 12, and then t is square and is 1 0. If I substitute, it's going to be 1 minus 12 0, so my answer becomes 12, and that is my answer. Okay, now I'm going to be applying line integral, fundamental theorem of line integral, and see how does it go. Since I don't need a lot of space, I'm going to be doing here my line integral. I'm going to be doing here. And the theorem is, our theorem is basically, I already wrote, we're just writing the function. On the left side, I'm writing what I need to be solved, and right side is the one I'm going to be solving. Okay, so I can simply just taking the function and f dr equals to, I can write the function, the first coordinate, which this is how we wrote earlier, right? This is my line integral theorem. All I can say this can be solved like this. I take the function, substitute the value, and the value is 2 comma 2. If I substitute 2 into the function, which is 2x 4y, I can substitute 0 0. So I'm gonna say this. Okay, if I substitute 2 into my function, it becomes 2 plus 8, which is gonna be 4 plus 8. 2 times 2 is 4, and then 2 times 4, 2 8, 4 times 8, 2 is 8, and then plus, sorry, not plus, it's going to be minus with this. Minus is 0 plus 0. When you solve it, the answer would be again 12. Right. You see, in one shot, we just solved this one. Let's move on. Take a look for some other problem which is giving a little bit more complicated functions. So what we have here, the problem is giving an example, and here evaluate. Remember, in this problem, nobody talk about which theorem you're going to be using. We have to decide it by looking this C. It's very important that I keep repeating. This C is telling us this is a curve, so should be a line integral apply. And the function is giving cos pi x plus sine pi y. Okay, minus x, y, z. So these are the function, and C is any path that start at this 1 half 2 and end 2 1 minus 1. So what you're gonna do, first thing first, we need to understand this is not in the question, nothing is giving about this is a line integral. I need to know the C is gonna tell me something. Another thing is that this is a 3D problem or 3D field, right? So we have 3D, so we are adding x, y, and then z. We already talked about that kind of problems when we did the line integral. What we're gonna do, we try to use fundamental theorem of line integral to solve this problem. We will be solving okay. Let's RT starting from A and ending to B. Be any path that start. This is given in the problem. That start 1 half 2 and end at 2 1 minus 1. Then RA, my RA, which is my position vector, pretty much a starting point, is going to be 1 half 2, and RB is going to be, these are the coordinate of my point, 2, 1, minus 1. Okay. My integral is this is not what I need to be solving. I always keep repeating. I'm going to write on the right side what I'm solving. The left side is what I'm supposed to be found. And what I'm gonna take the function and substitute the value for 2, 1, minus 1. Why? Because this function is ending. This is my end limit. This is not a vector, guys. This is function. I'm just writing this so I can substitute the value into my function. Just like that. Now I'm going to take the value and substitute into my function, and my function is this. Okay, so let's substitute. Wherever the x is, we're going to substitute 2. So cos 2 pi plus sine pi y, and y is 1, so it's going to be just pi, minus 2 and 1 and minus 1. Okay, these are the values I substitute. Then minus, I'm going to put maybe bigger parentheses just to be clear. I think I put this guys into one parenthesis, this guy's in another parenthesis, so we are clear. Cos pi plus sine pi by 2 minus 1, then half, then 2. Few things can be simplified, but not much. So this 2 and this 2, if you solve this one, the answer would be 1 and minus 2 plus 1 is going to be 3. So cos, this becomes 1. I think this becomes 1. And when we solve this thing, the answer will be coming for 4. So this one becomes 2 plus 2. This one becomes plus 2. This one becomes plus 1 after multiplying this. So 3, and then one of them is supposed to be 1. We got 4. So my answer is 4. Right? If you try to solve this problem with the traditional method of line integral, it's going to take a very long time and require a lot of efforts as well. Let's look other problems as we practicing. Another problem here. Evaluate dr where fxy equals to x cubed 3 minus y plus 4y, and c is given by, and c is my curve, by the way, c is given by this r. This time is given in the parametric form, 3 minus t square 5 minus t. With t equals, t have two limit, with t equals to, t go from somewhere to somewhere, and the somewhere is minus 2 to 3. So think about it. I just want to be clarified. In earlier question, we have the function giving pretty much like this. Right? If you go back, function is giving pretty much some other function, but is in the same format in a ballpark. But the way the r is given in the previous function question is basically two coordinate system. So I'm going to come here. Let's suppose this is my curve. I'm going to be calculating. This is my A, this is my B. I don't know how it's going to be look like. I'm just talking about why and how this R in the form of parametric. Earlier question, if you think about it, it can also be done in the same way the one I'm doing right now. If you have two coordinate system and you can use this x equals to x naught plus at, y equals to y naught plus bt, and z equals to z naught plus ct. If I start with this, that would be my 1 is my x naught is 1, y naught is half. It's up to me, to be honest. I just pick this point is x naught, y naught is z naught, and I can just calculate x naught plus at equals to 2 minus 1 will be 1, and then t. Same thing I can write with half plus something dt ct. So bottom line is that, and then I can just take this guy, this guy, this guy, and then writing here in the form of parametric coordinate. So the bottom line is that if you get the two coordinate, you can convert into parametric equation, and you can write just like here you written this x, this is y, this is x, this is y. However, make sure the two values of t you select, if you substitute this in this equation, you should get in the initial coordinate, and when you're substituting this, you're gonna get the final coordinate, which is whatever is given. So here we have no coordinate given, so we don't have to worry about it, because in this question this value is given to you. You don't have to do anything. But if you have to do your own math, that's how you're going to be doing your math to create those parametric equation, where you substitute first value of t, you get first coordinate, both x and y, and when you're substituting second value of t, you should get in your second coordinate both x and y values. Okay, so this is how things are working. But let's solve this problem with line integral. So I'm going to say solution r minus 2. See, I take the rt and substituting the value here, pretty much same way the earlier I use the given coordinate x and y. So I'm going to substitute here. It's going to be the two values substituting, so 3, 2 minus 2 is going to be minus 1 comma 7, right? This is minus 2 minus 5 is going to be, sorry, minus 2 plus 5, and then this minus is going to be plus 2 plus 5 is going to be 7, and here is going to be substituting 2 times 2 is 4, so minus 4 plus 3 is going to be minus 1. The other side of the coordinate, I'm going to be substituting with 3 with rt, so I substitute the t equals to 3, and it's going to be minus 6 and 2. Okay, 3 is going to be 3 times 3 is 9, 9 minus 3 is minus 6, and 5 minus 3 is 2. We got two values. We can also think r minus 2 and r3 are 2 and coordinates, 2 points on curve. So really I can say this a is my first coordinate, and which one is that? Minus 1 3. I can also write here minus 1 7, and the second coordinate is minus 6 2. So this question, actually going back to the first question, you just change the form, because you need to convert everything in the coordinate form so you can substitute the values into the function, and you need the values because function is given in the form of xy. See, the problem is earlier function is giving in x form y, but vector r is given xy's format as well. In this question, function is given in the xy form, but vector r is given in the parametric form. So what I should do, I should have to convert the parametric into rectangular coordinate to substitute it. So there's a lot of back and forth references in this topic, but we just want to be clear we are understanding what we are doing in this topic. Oops, yeah. And then I'm going to be substituting the r with -2. Right, this is how I write, this is what I need to be solved, and this is what I'm using to be solved. And I'm going to substitute this with -6 comma 2 minus function -1 comma 7. Okay, I'm going to take this -6 and substituting here. So -6 cube 3 minus 2 times 2 square minus, and I'm going to substituting -1, so -1 cube 3 minus 7 square. Okay, and if you solve these two, the answer is going to be 224 minus 74. The answer is 150. Okay, let's looking another problem for fundamental theorem of line integral. Suppose f is given like this. We also knowing that f is a conservative and independent of path. With a potential function of 5xy minus y cube. Okay, the two things I'm going to be repeat. We already talked about the conservative and independent of path and a potential function. So conservative or independent of path, I told you, is like few times field is like, field is independent to the path. So if I want to go from A to B, really I can go this way, I can go this way, I can go any other track, I can follow this track, I can follow this track. I want to go from A to B, I can follow whatever I want. The path does not really matter. I can go all the way down this way. The amount of work I'm going to be doing is pretty same. The amount of work is going to be doing is pretty same. Just like you taking the elevators. When you take the elevators in the building, you are not doing work to carry yourself on the stairs, but elevator's motor actually burning the same amount of calories or energy to pull you up. So if you want to walk by stairs, we burn our calories. And if you don't want to walk, we use elevators. Actually, elevators also, calories is a unit of energy, it's just too small, and joule is a little bit different. So we use joules to calculate that work. So it's pretty much same. Another thing is talking about the potential function. The potential function is that usually I give you function like x squared plus 3y plus y squared, and then remember we talk about that the 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 criteria or the test for conservative is this. Remember this? So right now what's happened, I'm giving you this and that. This is the x coordinate, this is the y coordinate of the function at that point, and the function is this. That's called potential function. The function who follow the conservative field, that is called potential function. So what I'm going to be doing, I'm going to be just solving this the way I solved the previous problem. It's just a little bit different in the given form. We can use fundamental theorem of line integral. Real quick, we're writing like usually here. Sometimes the C actually written right underneath, sometimes C is written right a little bit here. And make sure we pick up this time just not the only integral and then there is a C. Sometimes they write like a bigger C, right? So you don't be confused, it's all C. And we're going to be just doing inside, we want to solve this gradient f r t dot dr. This is what we need to be solved. And the line integral theorem, a fundamental line integral theorem, says you can do this by quickly doing b minus f a. Okay, so all I can do is just take this, substituting 0 comma 0 and then 2 comma 1, and I'm going to say this thing. This is given in the problem, the 2 coordinate at this point and then b this point. So I substitute these two, limit and then f dr. I can also write my function, and the upper limit is 2 comma 1, the lower limit is 0 comma 0, and all I can do, I can also write this is f 2 comma 1 minus f 0 comma 0, and all I do is just substitute the value. So 4x cubed, I take the integral of the function, so 4x cubed plus 3y squared x plus 5xy minus y cubed. This is a given function, and the 2 limit we already know. So let's substitute 4 2 cube plus 3 1 square, then 2 plus 5 2 1, right, minus 1 cube is 1, then minus, if I substitute here x and y value 0, I know it's going to be 0, so we don't have to worry about it. So it's going to be, if you solve this, it's going to be 2 times 2, 8 times 24, 32 plus 6, 38 plus 37 plus 38 plus 48 minus 1. So it's going to be 48 minus 1 will be 47.
Thank you for watching Knowledge Academy. Please subscribe my channel.